All right, guys. So today we're going to be talking about deductive reasoning. Okay. Deductive reasoning. Just to give you guys a heads up, because this is live, anything you say will be recorded and used for future. So please make sure that it is appropriate. If you do have a question you want to ask, you're more than welcome to ask while we're going over this. If not, just hold it until the very end. I'll let you know when the video is over, and then you can ask then. Deductive reasoning, okay, uses facts. So where we had talked before about inductive, where it was pattern, this will use facts. Like, today it is raining, I will wear my raincoat. Or if it is raining, I will wear my raincoat. And then you look outside, today it is raining. Therefore, I will wear my raincoat. That's a type of deductive reasoning. So it uses facts. It also uses accepted properties. Mathematical ones. Things that have been proven before. Definitions. And laws of logic. So here are some key main ideas. There are two big things whenever it comes to deductive reasoning. There's the law of detachment and the law of syllogism. So law of detachment says that if your hypothesis of a true conditional statement is true, then the conclusion is also true. So going back to my rainy day type of example, here's another one. If today is Tuesday, then we will eat tacos. Today is Tuesday, therefore we will eat tacos. So that's your conclusion. Where it gets a little tricky is whenever they say something like, if today is Tuesday, then we will eat tacos, and then it says, we will eat tacos, and they jump right to the conclusion. It's what we call invalid. You can't prove something if you jump right to the conclusion. You have to state the hypothesis first in order to make sure that a conclusion is true. So that's kind of the law of detachment. Notice how there's an if-then. Here's a bigger hint too. There's an if-then statement, and then all of a sudden the next statement underneath is just a statement. No if, no then, just a statement. Then it draws a conclusion. That's law of detachment. Law of syllogism, okay, works a little bit different. So the way that it goes is it says, if the hypothesis of P, whatever that is, then the conclusion of Q, and then if the hypothesis is then Q, then the conclusion of R will occur. Notice how it's using two if-then statements. Then if the hypothesis of P, then the conclusion of R. So to break it down for you, very simple. The way that this works is if P, then Q. If Q, then R. I'll get to what R is in a minute here. I'll show you. Then P, if P, then R. I guess I could write that over here. Sorry. P to Q, Q to R, P to R. That's what we're kind of aiming for. And everything is an if-then statement. Law of detachment, only one sentence is an if-then statement. Law of syllogism, every statement going through is going to be an if-then statement. That's a big way to see the difference between the two whenever you're asked which which it is for detachment. So here's an example. If we do not have electrical power, then the refrigerator cannot run. If the refrigerator cannot run, then the food will spoil. So if we do not have electrical power, then the food will spoil. That's pretty much it. Nothing super terrible. Okay. So let's take a look at some of these worked out examples. Okay. I'm just going to go over these first two in the video for you. That way you have them. And then there's a little check for understanding. I'm going to shut this off, and then I'll let you guys work on that for a little bit. So if two segments have the same length, then they are congruent. You know that BC is equal to XY. Using the law of detachment, what statement can you make? So right here it gives you a law of detachment. So it's either going to be something that's true or something that's not true. So if two segments have the same length, then they are congruent. BC is equal to XY. So if you know that they're equal, they have the same length, using law of detachment, what statement can you make? That they're both congruent. And that's basically it. So then using that, you'd say BC is congruent to XY. Remember, equality and congruency, even though they are related, they are just a little bit different. Yeah, question.
What is that like? Is that like a 2 above the equal sign?
It's called a tilde. It's just a notation for congruency.
Oh wait.
So like, remember, equal. That's a good question. Equal is just the two lines. Congruence is the two signs with the tilde over top. I call it a tilde. That's what my Spanish teacher called it way back when. So that would be that.
What's the difference between equal and congruent?
So the difference between equal and congruence, and we can get into that in a different lesson, but the difference between equals and congruence is equal shows measure length. Like usually there's a definitive number. Like for instance, BC is equal to 12, XY is equal to 12. With congruence, it's showing that two segments are, quote, equal. So it says, like, you'd say that BC was congruent to XY. Instead of actually showing the number, you just say that they are both essentially equal to each other. Let's look at number 2 here. If possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So in letter A, it says if x squared is greater than 25, then x squared is greater than 20. On the next one, it says then if x is greater than 5, then x squared is greater than 25. So it's kind of flipped around a little bit from what we've seen. But if you notice, we've got a statement that is the same here and the same here. So remember the whole, let me go back to it, like P to Q, okay, Q to R, therefore then P to R. Okay, that's what we're trying to get to. So in this case, since we have this same statement, that's going to be our Q. Think of that as our Q, which then makes this x is greater than 5 our P, and then x squared is greater than 20 our R. If you can kind of distinguish between those, the P, the Q, and the R, as to how it goes within your statement, then you shouldn't have any trouble with finding your conclusion. Your conclusion should be the P to R, which would be written if x is greater than 5, then x squared is greater than 20. Yeah, question?
Can you switch R and P?
You can, no. So if you switch, in this statement, if you switch R and P, then they're still P and R. They're just in different locations. You want to, let me put it this way, if Q is at the front for both of them, then it's invalid. You can't say it would be considered invalid, which is exactly what we're going to get to with letter B. So if a polygon is regular, then all the angles in the interior of the polygon are congruent. If a polygon is regular, then all its sides are congruent. So if you have two Q's that start, or even like two P's that start, it's considered invalid. So again, just a reminder, we're going P to Q, Q to R, which then should give us P to R. I see two things that repeat, but they're both in the very front. So this would be P and this would be P. You could technically say that this is Q and this is R. You can only have, if you look at this, you can only have two Qs. You can't have two Ps, and you can't have two Rs. So therefore, this is not possible, or invalid is what we call it.